Hi, Assalamualaikum. My name is Muhammad Aim Razim Ramzi. Now I'm going to present about analysis and method of inspection of this accident. First, let me introduce to this accident. The explosion was from the fluid catalytic cracker (FCC) unit, and its function is to transforming heavy hydrocarbon into useful lighter products, including petrol and another product. So by decompose big hydrocarbon into smaller and more valuable compound via a catalytic cracking process. So how FCC unit function is the heavy hydrocarbon vapor mixed with catalyst in the reactor, then catalyst particle touch the hydrocarbon in the riser, and both of the chemical evaporated. Then hydrocarbon vapor converted into lighter hydrocarbon as they travel up the reactor and converted into hydrocarbon product in the main distillation column. So the analysis of the accident is first to prevent the hydrocarbon from flowing back into regenerator and electrostatic precipitator or ESP unit. Side valve and catalyst are meant to keep a catalyst barrier between the two pieces of equipment. So unfortunately, the span side valve, where the span catalyst flow from reactor to regenerator, cannot maintain the catalyst barrier in the reactor due to the corrosion, even though it closed. Because of that, the explosion occur when the hydrocarbon vapor contact with the ESP unit. So we suspected that the causes of the corrosion came from the flue gas content. The flue gas content consists of carbon dioxide, uh, water vapor, nitrogen oxide, sulfur dioxide, particulate matter, oxygen, and contamination, trace of contamination. So each chemical present, they have their own corrosive mechanism, and with all that combined, no wonder the side valve were heavily corroded. Plus, with the high temperature condition in the reactor, speed up the corrosion environment.
For the direct and indirect consequences of the accident. So for the direct is infrastructure damage, which is the refinery storage tank, pipe and processing facility most certainly sustain major damage as an outcome of the explosion. So for the second is injuries and fatalities, which is workers suffer injuries as a result of the explosion. So for the third is environmental damage, which is hazardous material are frequently released into the air as a result of the refinery explosion. So for the indirect consequences is legal action may be brought against the Exonmobil because harm communities, environmental organization, or wounded workers. So for the second is community concern, which is a local communities near the refinery may become more concerned about the safety of the facility and its potential impact on their health and well-being. So for the third is disrupt supply chain, which is this can affect not only Exxonmobil but also other business and industry that rely on the product produced by refinery.
Assalamualaikum. Today I'm going to present form of corrosion and damage mechanism. There is likely 5 types of corrosion and damage mechanism there. First is acid corrosion. It's caused by the presence of acids in crude oil, which attack and dissolve metal. Common type of acid corrosion is naphthenic acid corrosion. And then stress corrosion cracking, corrosion that occurs when the metal is subjected to both stress and corrosive environment. The third one is hydrogen induced cracking. occurs in high strength state when they are exposed to oxygen. And the fourth one is wear and erosion. The high pressure fluctuation during the explosion led to cavitation erosion. And lastly, sulfide stress corrosion cracking occurs in the presence of hydrogen sulfide and other sulfur-containing compound, aggressive toward carbon steel, which was the material used for the SCSV. My name is Muhammad Shazwan. Today I'm going to present about mitigation method. There's 4 suggested mitigation methods. First is corrosion risk assessment. Consideration include process composition, presence of pollutants such as H2S, chloride, and corrosive agent, as well as operating temperature and pressure. Secondly, material selection can be done by considering corrosion resistant by prioritize material that high resistance type of corrosion. Third one is corrosion monitoring, practice of observing and measuring the rate, extent of corrosion over time. And lastly is protective measure, use of coating, catalytic protection, and utilizing chemical treatment. Thank you.
For the other losses may happen if corrosion monitor program not conduct. Unplanned shutdowns and production disruption. Corrosion can cause of equipment failure in refinery, and planned shutdown can have a significant impact on the production and profitability. Increased maintenance costs, which is corrosion can cause significant damage to the equipment, so leading to the more frequent and expensive maintenance that stay in the ESME standard code. So for the last is safety hazard and environmental risk and damage. As the Exonmobil incident demonstrate that undetected corrosion can lead to the equipment failure, which is can leak of the flammable hydrocarbon and potential catastrophic fire and explosion. That's all.
So, to prevent this catastrophe from happening again, inspection is required to guarantee the unit's correct operation and safety. So the first step is to conduct visual inspection. It is the first step to identify overall condition of components. The objective is to check to see if there any clear sign of damage, wear, or other issues on the component. Second method is to conduct a non-destructive test or NDT to evaluate the exterior and interior state of component that naked eye can't see. So we suggested that UT and RT for finding interior defect, cracking, or changes in thickness, and DPT and MPT for finding small flaw or crack at the exterior of the component. So the third method is to conduct corrosion monitoring inspection in order to evaluate and alleviate the detrimental effect of corrosion on this vital component. By using corrosion coupon, which is to retrieve significant information regarding the degree of material deterioration, and another method is to use electrochemical probe, which to facilitate the continuous observation of corrosion rate, thereby providing continuous awareness of corrosive surrounding. So, as a conclusion, safety is a top priority in any field of production, especially in the refinery business. Through careful maintenance methods, compliance with safety standards and regulation is maintained, resulting in a secure working environment for people and adjacent communities. The facility infrastructure and equipment are conserved by addressing wear and tear, corrosion, and other kind of deterioration as soon as possible to prolong their operation life and to reduce costs. So thank you for me. Assalamualaikum.